Assalamualaikum and hi. Today, our group gonna present about the experiment that we have done, which is the title is water balloon parachute pump. So this is our members, which is we have Muhammad Numan Hakim, Nur Nazlatul Dania, Nurul Fatina Najwa, which is me, and Putri Farahin. So hi, first I'm gonna give some introduction, which where gravity is a natural force that pulls object towards the earth. So when an object is dropped, gravity causes it to accelerate as it falls. However, air resistance, also known as a drag, acts in the opposite direction, which slowing the object's fall. So parachutes are designed to increase air resistance and reduce the speed of descent, which help to minimize the impact when the object hit the ground. So a parachute is pushed downward by gravity and upward by air resistance. The parachute remains in the air longer when there is more air resistance, such in a high wind. So the downward pressure of gravity increases with the weight of the object tied to the parachute.
Okay, so next is objective. There are three objectives for wet clothes in box parachute for water balloons. First, to understand the basic concept of work energy and its relationship with mathematics in calculation. Second is to apply the concept of work energy and its relationship with mathematics in calculation during the wet closed in box parachute for water balloons activity and determine the related data. Last but not least is to present the group output of analyzed data using tracker by Canva poster.
Alright, so next I'm gonna explain about how to make this experiment, which is the procedure. So first and foremost, our group make a parachute which contains a box, plastic bags, string and clothes which is used as it secure the balloon. So after we make a parachute, we will fill the balloons with water to the same size. So after we fill all the balloons with water, we will use three different level and we will measure it each height. So after that, we will drop a balloon without a parachute first from the first height, and then we will take the how long time the water balloons falling down and observe either the water balloon is burst or not. So next, we will repeat all the step to the others too high. Okay, after that, after settle all that, we're gonna repeat all step just now with a balloon with a parachute from the same height as the previous one. So after we drop all the water balloons, we need to take the time and observe again. After all the time, we need to analyze all the data, and we use tracker software, and we plot the graph based on the data that we receive.
So next, I will be continue on presenting on the analysis of graph using tracker. So the first part will be the balloon without parachute. As we can see, there are two different graphs. At the top panel, XVS time graph. This graph shows the horizontal x-axis motions of the parachute water balloon over time. At the bottom panel, YVS time graph, this graph represents the vertical y-axis motions of the parachute water balloon, which was the free fall itself. From the observations at the graph XVS time, at level 1, the balloon had a minimal horizontal displacement because it had a little sideways motion. At level 2, it was slightly greater horizontal displacement, And meanwhile, at level 3, it was the most noticeable horizontal displacement. And from the graph YVS time, the observations that we can see at level 1, the balloon had a short fall time because it had a quick fall due to the shorter head of falling point. At level 2, the balloon had a longer fall time compared to the balloon at level 1 due to a higher starting point. At level 3, its descent was the longest due to the highest position. So next, for the second part, balloon with parachute, as we can see from the top panel, X vs time graph, this oscillating pattern shows the changes in horizontal velocity due to air resistance, wind, or design instability. So based on the observations from the graph X vs time, at level 1, we can see there are more stable horizontal motion due to the shorter falling time. At level 2, it was more swing or uneven horizontal motion due to the longer falling duration. At level 3, it was more noticeable instability in horizontal motion due to the effect of wind or external factors. And from the graph of YVS time, we can see at level 1, the balloon had a shorter falling time due to the lower head. So, the parachute has a limited time to stabilize the velocity. At level 2, the balloon had a longer falling time, so the parachute slows the falls more effectively. At level 3, the balloon had a longer falling time, and the parachute has the most time to act effectively to stabilize the fall.
Assalamualaikum warahmatullahi wabarakatuh, and good morning to Doctor and fellow friends. So next we will continue with discussion which will I focus for balloon without parachute and balloon with parachute. We did an experiment with water balloon to see how falling height and air resistance affect their motion and impact. Without a parachute, the balloon fell faster and hit the ground with more force as the height increased. This is because the energy they gain from being lifted higher turned into greater movement energy during the fall, causing them to burst on impact. When we use a parachute, it slowed the balloon fall by increasing air resistance, allowing more to stabilize. At higher level, the parachute worked even better, reducing the impact force and preventing the balloon from bursting. The horizontal motion also showed more oscillation due to wind and air resistance at greater height. Next, this experiment isn't just for assignment, but it's a real-world concept. Parachute like those used in space missions help slow down objects with high energy to ensure safe landing. Understanding how energy changes during motion teaches us how to control impacts, whether in experiment or practical application like design safety device. Thank you.
Next is conclusion. Conclusion for this experiment is the experiment shows that water balloons without protection burst when dropped from various heights due to the direct impact forces, while balloons covered with wet cloth remain intact, even from the highest drop. The wet cloth effectively absorbed and distributed the impact energy, reducing the pressure on the balloons. This highlights the importance of cushioning and minimizing damage caused by free fall impacts. Additionally, the result demonstrates that as the height increase, the velocity of the falling balloons also increase, aligning with the principle of work energy and gravitational acceleration. The use of the wet cloth illustrates a practical application of energy absorption, showing how protective materials can be used to safeguard fragile objects in real life scenarios.